Hello friends, welcome to our channel. So in this video I am going to discuss about the spinel, and I'll show you that how easily you can identify that spinel will be normal or inverse. I think that you all know about this spinel very much. You are well aware about that. But what happens that question paper, if you are asked that you can be asked two three this kind of complex compound will be given, and you will be asked that which one will be normal and which one will be inverse. So in that case you may get confusion, and that time you may get wrong answer. But here I will show one simple way, or you can say the simple trick. So using that you can find your answer correctly and within few seconds. So before going to that part, that how I can find that spinel. So here I want to mention the trivial thing or the basic thing about spinel. I know that you all know about these things, but again I want to tell another time. So what is spinel? Spinel is nothing but the mixed oxide. AB2O4 is the general term. So it is A, that is divalent, the divalent cation, and B will be trivalent cation for spinel. And the number of divalent cation will be 1, and the number of trivalent cation will be 2. And this spinel can be divided into two parts, that is normal spinel, and another one is normal spinel, another is inverse spinel. Okay, in case of normal spinel, this AB2O4 general formula will be followed. So A will be having divalent plus 2 charge, for B it will be plus 3 charge. But in case of inverse spinel, what will happen, that 1B2 1B, this element, or generally it is metal, so one metal will be replaced by this divalent cation or divalent metal. So one trivalent metal will be replaced by divalent metal. And another thing that in case of spinel, both tetrahedral and octahedral hole are present. So in case of normal spinel, what will happen, the divalent cation, that is A, that will be situated in tetrahedral hole, but both the trivalent cation, that will be situated in octahedral hole. But in case of inverse spinel, what will happen, one, this trivalent cation from this octahedral hole will be shifted by this divalent cation that was present in the tetrahedral hole for normal spinel, but in this case it will come to octahedral hole, and one trivalent cation, that is B, that will be shifted to tetrahedral hole. So by seeing this, you can see the difference between the spinel, that is normal, and between you can see the difference between normal spinel as well as the inverse spinel. And if you look carefully, so you can see that in case of inverse spinel, and if I consider this bracket for both the case is the zone for octahedral hole, so you can see in case of inverse spinel, one, this divalent cation has come to the octahedral hole, and one B, that is trivalent cation, has been shifted to tetrahedral hole. So if I consider this octahedral hole only, so in case of inverse spinel, one this divalent cation has come, and this trivalent cation has been gone actually. So if we take that part, so we can say that if the CFSE of this divalent cation is more in the octahedral hole, that time only it can replace the trivalent cation. Otherwise it cannot replace the trivalent cation, because trivalent cation generally wants to stay in the octahedral hole. So what I am trying to say, again I am repeating, that the divalent cation in the octahedral hole, if it has the more CFSE, that will give the stability to the overall system. So we have to consider the CFSE, and if the CFSE of the divalent cation in octahedral hole, if that is more compared to the CFSE of trivalent cation in the octahedral hole, that time you can get the inverse spinel. So same thing I have written here. So we have to remember this thing only. So in case of inverse spinel, the CFSE of this divalent cation in octahedral hole will be more compared to the trivalent cation in octahedral hole. But in normal spinel, that is the opposite case. So when the CFSE of this trivalent cation will be more in octahedral hole, that time this divalent cation cannot replace it. So in that case, we will get the normal spinel, that is AB2O4. So keep this thing in mind. So what we have to do, we have to only calculate the CFSE of this divalent cation and one trivalent cation in octahedral hole. And if we find this, and the CFSE of this divalent cation in octahedral hole is more, so that time it will give us inverse spinel. But if you find that the trivalent cation in octahedral hole has the more CFSE, that means more stability, that time you know that normal spinel will be formed. So these things only we will remember. So if we can calculate only the CFSE of this divalent cation and trivalent cation, from that only we can tell that what will be the nature of our spinel, that will be normal or inverse. And in case of spinel, you can see this oxide is present, 4 oxide ion are present, so that is weak field ligand. So it will generate the whole complex, you can say that will be high spin complex. So due to the presence of this oxide ion, whatever the complex will form, that will be high spin complex, because the oxide is weak field ligand. So in this case also, this divalent cation or divalent metal or trivalent cation or metal, they will stay as a in their high spin state because of the presence of this weak field oxide ions. So that these things also keep in your mind, that always this A, B, they will be situated in high spin state. One exception is there, that I will come later, but in general they will be in high spin state. Now I'll show the example that I have taken one. The question is, among the compounds Fe3O4, NiFe2O4, Mn3O4. So the the statements are given. So they are asking that among them, which one will be normal spinel or which one will be inverse spinel. That means what will be the nature of them. And here you can see Fe3O4, that means we can think it about as a Fe2O4, that means it is having the general formula of spinel. Similarly NiFe2O4, that is also having the general formula of spinel as well as the Mn3O4. So if I consider the NiFe2O4, so I have told that I will only calculate the CFSE of A2 and B3 in octahedral hole. So in case of NiFe2O4, I will calculate the CFSE of Ni2 plus, because in case of NiFe2O4, Ni is the having the +2 charge, and I have told that only we will calculate the CFSE in octahedral hole. And as I have told that this metal will having high spin state, so if you calculate the CFSE of Ni2 plus in octahedral hole, that time you will get this minus 1.2 del octahedral. That I didn't calculate. I am not saying the CFSE, how we can calculate the CFSE. I think you all know, but if you don't know, that time you can check any of the resources. That is very easy to calculate. So if I come to this question, so the CFSE of Ni2 plus in octahedral hole will be minus 1.2 delta octahedral, but the CFSE of Fe3 plus for this Fe2, so Fe3 plus I am considering that is a trivalent metal, So in CFSE of Fe3 plus in octahedral will be 0 del octahedral. So from these two value you can understand that CFSE of Ni2 plus in octahedral hole is more. Negative means more stability. So the CFSE of Ni2 plus in octahedral is more compared to this Fe3 plus. So what will happen? This Ni2 plus will replace one Fe3 plus from the octahedral hole, because if Ni2 plus goes to octahedral hole, the overall system will gain CFSE. So that time overall system will be stabilized. So this NiFe2O4 is a inverted spinel. Similarly, Fe3O4, here I have written the spinel formula, spinel kind of formula, that is Fe2O4. This Fe having plus 2 charge and this 2 Fe having plus 3 charge. So again I am calculating the CFSE of high spin Fe2 plus in octahedral hole. So I am getting minus 0.4 delta octahedral, the CFSE for this Fe2 plus in octahedral hole. But the CFSE of high spin Fe3 plus, that is D5 system. So high spin Fe3 plus having the CFSE, that is 0 delta octahedral. That means in octahedral hole the CFSE of this high spin Fe2 plus is more. So what will happen? This Fe2 plus will replace one Fe3 plus from the octahedral hole. So in this case also we will get the inverse spinel. In case of Mn3O4, if I calculate the high spin Mn2 plus CFSE in octahedral hole, that is 0 delta octahedral. But in case of high spin Mn3 plus, the CFSE we are getting minus 0.6 delta octahedral. That means in case of high spin Mn3 plus, the system is gaining more CFSE. That means the system is becoming more stabilized when the Mn3 plus is present in the octahedral hole. That time Mn2 plus cannot replace this Mn3 plus. So in this case the Mn3O4 will show the feature of normal spinel. So here you can see this NiFe2O4 and Fe3O4 will show the characteristics of inverted spinel. Not inverted, that is inverse spinel. So the option D is the correct answer in this case. So here you can see that how easily I can calculate. Only what I have to do, again I am summarizing the thing. I have to calculate the CFSE of this divalent cation, and I have to calculate the CFSE of trivalent cation. Both will be high spins in high spin state, and you have to calculate the CFSE in octahedral hole only. So everything we are means compacting everything. So in an octahedral hole you have to calculate the CFSE, and you have to calculate the CFSE for divalent cation and trivalent cation. So from that I have told you the rule, and according to that you can get the this compound will be inverse spinel or normal spinel, that you can easily calculate. Now the second example that I have again showed here, that is Fe3O4 and CO3O4. So for Fe3O4 I have just shown that it will be inverse spinel, but in case of CO3O4, that I have told that one exception is there. So that is this cobalt system. In case of cobalt system, when cobalt is in plus 3 cobalt having plus 3 charge, so keep that in mind. Cobalt having plus 3 charge will always form low spin complex, except cobalt F6 system. Only in presence of fluorine cobalt forms high spin complex. In other case cobalt plus 3 system forms low spin complex. Okay, so in this case also we have to calculate the low spin cobalt 3 plus CFSE instead of high spin cobalt 3 plus, because this cobalt 3 plus will have the low spin state when it has this plus 3 charge, but in case of plus 2 charge it will have the high spin state. So only in this case you have to keep that this thing in mind. This is, you can say, one exception in except this case, in every case you have to consider only high spin, but for this cobalt 3 plus system you have to consider low spin state. So for low spin cobalt 3 plus in octahedral hole, the CFS is minus 2.4 delta octahedral, but high spin CO2 plus having the CFSC that is 0.8 delta octahedral. So from this also it is clear that the low spin cobalt 3 plus having the more CFSC. That means this cobalt 3 plus will try to be seated in the octahedral hole. So cobalt 2 plus cannot replace cobalt 3 plus from the octahedral hole. So in this case we will get the normal spinel. So in this way you can easily calculate, you can easily identify that your spinel system will be normal or it will be inverse spinel. Only you have to do that I have told. You have to calculate the CFSE of the metal having plus 2 charge, and you have to calculate the CFSE of the metal having the plus 3 charge, and then you have to compare their in which case the CFSE gain is more. So in that way you can tell that your spinel system will be normal or inverse. And I think I have tried my best to explain this simple way to identify the normal spinel as well as inverse spinel. If you find this video helpful, please press the like button and please share with your friends. And if you have any doubts or if you want to share your feedback, so please feel free to share with us so that we can do better job in future. Thank you for watching.